So ready, Peter? So we are going to start vectors. Wait, I'm sending the link after that I'm starting. See, patience in vectors is very much needed. And whenever you will be solving questions, you need to be very, very accurate in your work. Done, beta? Now listen, I have the link. Now we will start the work. Now everyone pay attention here. So when we will be discussing vectors, some things are very, very important. Vector is you need to understand few sections. Okay. Now why vector is implemented? To become direction specific. What we need vectors? We need vectors because we need to go direction specific. Understood? So this, because of that only, we are exactly discussing vectors. What we are discussing? We are discussing vectors to go direction specific. The next important point is if somebody will be asking that, okay, we can understand that vector is implementation of direction. That means anything which will have magnitude as well as direction will be considered as vectors. Understood? The one which will have direction and magnitude together will be considered as vector, beta. Okay. So now our most important thing, we will understand one by one few simple things so that we can be able to analyze this one. So directed line segment, such as the length of the line segment is magnitude of the vector, and direction of arrow marked at one end emphasizes the direction of the vector. So beta, whenever we are drawing a vector, we will be representing a vector by this line segment and this arrow. So this line, what it is exactly drawn, it will be exactly telling that this is the magnitude. This is the magnitude. An arrow is representing what? Direction. So if we will be drawing any vector like this, if we will drawing any one line like this, that means this is A and this part is B. So this is 5 meter. So this 5 meter is what, beta? This 5 meter is magnitude, and this B part is there. So that AB vector is exactly what? 5. Understood? So 5 meter AB vector. Why, beta? Because we have exactly drawn magnitude and direction both. We have drawn what? Magnitude and direction. So this is the most important topic about, this is most important point about vector. So vector holds for both magnitude and direction. Vector holds for both magnitude and direction. Understood? So next is a vector denoted by PQ is determined by point P to Q. So what we are doing is we are going from point P to Q. We are going from point P to Q and its direction is from P to Q. That means what? What is the start direction? The start direction is P and the another direction is Q. So since vector is direction specific, when you go opposite, it will become Q to P. When you go opposite, it will become what? Q to P, and then that time the magnitude will become negative. That time what will become negative? Magnitude will become negative. So that's the most important point about vector. AB vector means A to B. What is the initial point? A. What is the terminal point? B. BA means B to A. What is the initial point? B. What is the terminal point? A. So AB vector will always be negative of BA vector. AB vector will be negative of BA vector. AB vector will be exactly negative of BA vector. This is most important. One minute, beta. These people are so risk. I'm just this type of people's. I'm just. So this is exactly the most important thing is. So here vector part we have understood. Now we need to understand the next section. The point P is called as initial point and the point Q is called as terminal point. Now next important thing is vectors are generally denoted by a vector, b vector and c vector. So always arrow will be coming a vector top, b vector top and c vector. Now what is the meaning of modulus of a vector? So if somebody will be asking you about modulus of a vector, what answer you are going to give? Can you say me? Modulus of a vector means magnitude. So whenever modulus word should come in your brain, you should understand they are exactly denoting as magnitude. What it is denoting as? Magnitude. It is only denoting as magnitude. So this part is exactly denoting as magnitude. Okay. So now AB vector part will be there. So whenever you write AB vector, that is vector. But the moment you will write like this will become the magnitude of a vector. Magnitude of a vector. Understood? So now when you will be writing the magnitude, the direct section is coming as, look here, if AB vector is written as AB vector is written as xi unit yj plus z cap. So here when you are writing this one, so magnitude of this will become root under x square plus y square plus z square. This is exactly considered as magnitude of a vector. What it is considered as? Magnitude of a vector. This is considered as magnitude of a vector. Can we do it? This is considered as magnitude of a vector beta. So this is magnitude of a vector. We will do the next part. Magnitude of a vector. So now we are going to talk about magnitude of a vector afterwards. Now we are going to, because we have to solve. So every vector, PQ vector has following three characteristics. So you need to understand that the vectors are exactly enclosed by three characteristics. So first is origination of a vector. How we have originated a vector, what is the need of origination of vector, and why we have originated a vector. So there are three important massive questions for a vector we must understand. So the first part is every vector will have three important points. What are the three important points? Line, support and sense. What are they? Line, support and sense. Line is exactly coming from length. So line is giving you length. So length, support and sense. Sanjana, good evening. Length, support and sense. What it is? Length, support and sense. The third point is, please remember this one. Every vectors will have exactly what point? Length, support, sense. What it is there, beta? Length, support, sense. Smriti, good evening. So what it is called as, beta? Length, support and sense. So now what is the meaning of length? What is the meaning of support? And what is the meaning of sense? These are the three basic pillars of vectors. So now what is the meaning of three basic? So what is the meaning of length? When you take the magnitude, so this is exactly, can you see the dotted line? So this dotted line is representing a line. This dotted line is representing what? A line. And beta, when you will be starting from a point and going towards this one, this is exactly called as what? So this is exactly considered as length. So this part will become PQ. So whatever vector is there, its magnitude is considered as length. Its magnitude is considered as length. So every vector, whenever you will be drawing, they will give you a magnitude. What is the first point? The vectors will give you a magnitude. They'll never be away from a magnitude. Okay? They will never be away from a magnitude. So every vector will have what? Magnitude. So whenever a vector is having magnitude, it is exactly called as length. Got it? So the length will have some segment now. So length will have a line segment. So line segment, we can actually calculate them. Can we do what? We can actually calculate them. So when we are able to calculate them, they are considered as what, beta? Length. And they will have a line segment. Length will have a line segment. Okay. So now once we are exactly writing that, That is one of the most important point. Yes, Peter. So segment of a line but with a direction. Vector is a segment of a line with direction. So if vector is a segment of line with direction, it is exactly considered as that point. So now look here, Peter. So here this is line segment. This is magnitude. So what one we had understood that कि दो arrows are there, though those arrows are there, but arrows are indicating only direction. It will have a specific length. It will have a specific length. So vectors will have a specific length. No, no, not like that. So vectors will have a specific length. So first part we talked about length. Got it? And length will always be written like this. This is exactly the magnitude. Length will always be written like that, and that is called as what? Magnitude. Or it is considered as magnitude. Now second is called as support. Vectors are never out of support. Always a vector support is coming from a line. Understood? So this dotted is representing what? Line. So that means imagine beta that this room is full of lines in very uneven directions. From there, you are taking specific 2 points and showing direction. That means it is exactly coming as a support. The lines are coming as a support for vectors. The lines are coming as a support because beta from this line only we are going to make vector. Got it? Of specific length. Of specific length. Let's understand this one. This is exactly an endless line. Got it? Now in this endless line, what we did, we drew two vectors. Got it? Now these two vectors will be supposed to be parallel and collinear. These two vectors is supposed to be what? Parallel and collinear both. These two vectors are supposed to be what beta? Parallel and collinear. These two vectors are supposed to be in vectors it is sense. See, because see, it is coming from the same support. Listen very carefully. It is coming from the same support. So they will be exactly some distance away. So if you will cut the line into two, they will come parallel. Understood? So they are also called as, so they will be considered for 2 points. One, they were going to say that parallel, and second point, they will be calling it as collinear. Understood? So collinear will have one common contact. Parallel will not have. Algebra part, I am going to represent this as, in a very simple tone, I am going to explain that beta. See, now understand this section. This is exactly a line segment. Got it? So now beta, in this line segment, you drew two vectors. One vector is like this. Another vector is also like this. Got it? So now these two are exactly considered as same line vector. They are exactly considered as what beta? Same line vectors. So when you will be writing it as, and somebody told you that A, B and they have a common contact and C, then how to prove that they are collinear? At the case of collinear, AB vector is equal to lambda BC vector. Understood? So they are representing collinear. Or AC vector is equal to lambda BC vector. What is collinear and parallel? Beta, collinear means lying on same line. Lying on same line. So it can't be parallel. No, collinear in common concepts we are not calling it as collinear, but at the concept when we are understanding this part, for parallel collinear is different for normal, but for vectors, since they are exactly having the same support, so support sense is exactly same. See, vector is just, we are going to denote it as a line. Vector, what we are going to denote it as? We are going to denote a vector as a line. And that time what we are doing is, when we are denoting a vector as a line, the vectors will be coming from the same support. The vector will be coming from what? Same support. That's a very, very crucial point. The vectors will be coming as a same support. Understood? So here it is exactly considered as collinear. Understood? Now two parallel lines are there. And now we are taking the vectors from two parallel lines. Got it? Now this is AB and this is CD. Now AB will be lambda CD. This is for parallel. That means no common points are there in the contact. But for collinear, did you saw one thing? AB, B is coming repeated. and AC, C is coming repeated. Either you can say AC is equal to lambda BC, understood, or also we can say AC vector is equal to lambda AB vector, understood. So these three ways we are representing collinear. Note down, these things are the most important part. Again and again you will not be getting all these notes, so you need to understand what is the difference between parallel and beta. This is the more sense, it makes sense, and vectors are very very important to be noted. So note down. So what is the line? Line is acting as what? Line is acting as a support. Line is acting as a support, and we are getting lines length from that support. We are getting length from that support. This is the most crucial part. I hope you might have understood. Those who have joined the sessions, please kindly. I hope you might have understood, beta. Till here, is it okay? Okay. Now we will do the same part. Sense support understood na beta. What is sense? Line. Or sense is what? Say length, sense, and support. Length, sense, and support. Length we understood. We are calling length as magnitude. We are calling length as magnitude. Support is line. Sense is direction. What is sense? Direction. So vector is direction specific. Let's check this one out. Sense is direction. Now look here, beta. So the sense of PQ is from P to Q. Now check, beta. The sense of PQ is from P to Q, or the sense of QP is from Q to P. So that means sense is talking about direction. Sense is talking about what, beta? Sense talks about direction. So what and all we have learned? We have learned that vector is having three important parts. What are the three important parts? Length. Length means very good. Length means magnitude. Support. Support means the line on which the vector is drawn, and the line can keep two vectors, and they both vectors will be parallel. Sivaranjani, that's not good. I'm started vectors and you people are so late. Now look here. So that means what, beta? This part support means support is a line. And what is the sense? Sense is direction. The entire concept of vector is dependent on three important sections: length, sense, support. What and all are that? Length, sense, and support. So length means magnitude, support means line, and sense means direction. So support, length, and sense, these are the three important points to be noted. I hope you might have understood now. So vector 1 point is clear now. And the next important sections, what we have done is, we talked about if a line is exactly, now can you say me, if on a vector, I will draw two vectors. What are they, beta? Are they collinear or are they parallel? They can be parallel. So if I'm drawing like this one, and in that I drew two vectors like this, So they can be parallel and they can be collinear. If they are linked, then they are collinear. If they are non-linked, means they are parallel. So the concept of vector is very vibrant and they will be exactly like this. So support sections also. So here we understood now. So these two are two lines, and from these two lines we took two vectors. So what we wrote? AB vector is equal to lambda CD vector. So these two lines are giving the two vectors. But here one line itself is giving the two vectors. But here with this total is exactly coming and they are telling prove that it is collinear. How to prove it is collinear? AB vector is equal to lambda BC. AC is equal to lambda AB. AC is equal to lambda BC. So these are the ways through which we can prove that the vectors are what? Collinears. And parallel means if it will be on the same support, if two vectors are exactly drawn. So you are drawing like this and you have named it as AB and CD, then what you are going to write? AB vector is equal to lambda CD vector. That means what beta, what is the conclusion we have drawn? We have drawn a conclusion that two vectors when they will be parallel, they can be exactly coming from two lines. And presentation is AB vector is equal to lambda CD. And same line also can give you two parallel vectors. Understood? And that time presentation also will be AB vector lambda BC. And when same line will be there, then it will be either representing a parallel or it can be representing a collinear. That time if it is representing a collinear, that time there will be one alphabet common. Like AB, BC, what is common? B. AC, BC, what is common? C. AB, AC, what is common? A. So that is representation of vector. Is it the basics of vector is now clear, beta? So this is so only I am telling you vector in. Yes, beta, same. But beta, when they will be away from each other, na, then only we are taking. Okay. So I am distinction holder 92 in vectors in MS 11. And look here, beta. Next part is equality. So when two vectors can be, we make two vectors equal. The most important topic, vectors equal means magnitude wise they have to be equal and direction wise they have to be equal. So beta, if this is vector AB and this is vector CD. So first thing is magnitude. AB vector magnitude is equal to CD vector magnitude. So magnitude wise both the vectors are equal. First thing. And direction also is equal. So directions also so magnitude and direction when both are equal, they will be considered like that. I hope you might have understood. Got it, beta? So this is exactly the way we are proceeding the questions. Understood? So here, when two vectors are equal, what it is exactly, beta? Unequal vectors, the equivalent vectors may have same direction, but equivalent vectors can be of two different types. Equivalent vectors means maybe direction same, magnitude not same. Maybe direction same, magnitude not same, or maybe magnitude same, direction not same. So they will be considered as equivalent or unequal vectors. Understood? So this is exactly a very good catch. You need to understand that point very clearly. I hope it is clear to you. Huh? So if somebody will be asking you these questions, will you be able to answer what is the meaning of equivalent vectors and what is the meaning of equal vectors? So beta, if I will take like this, are they equal? Are they equal? Because see, direction is same. Direction is same. Here what is there? Direction is same. but magnitude is not same. Direction is same, but what is not same? Magnitude is not same. So since the direction is same and magnitude is not same, what it will be considered as, beta? It will be considered as equivalent vectors. Understood? Equivalent vectors means कि they will not be equal. They will not be equal. Unequal vectors means the direction also will not be equal. So when unequal vectors will be there, this is one vector, this is another vector. You see, this part is considered as AB and this part is considered as CD. So AB vector and CD vector is exactly there. So direction specifically, they are opposite. Direction specifically, they are opposite. So they are considered as, hello Himanshu, they will be considered as what, beta? They will be considered as unequal vectors. What they are considered as? Unequal vectors. I hope you might have understood this one. So this is exactly the case of equal vectors and unequal vectors and equivalent vectors. I hope you might have understood. Now beta, what is the meaning of zero vector? Now there is always a confusion about zero vector. Himanshu, थोड़ा सा आगे चले जाओ वीडियो में, तुमको सब कुछ पहले से मिल जाएगा. Just go fast. So now look here. You need to understand one thing. The next important point here is, हिमांशु एक बार थोड़ा सा आगे चले जाओ वीडियो का चेक करो. So now here the modulus of the null vector is 0, but it can be thought of having any line. See, please understand, there is always a confusion about null vector or zero vector. So let's clear that confusion about null vector or zero vector. Okay, super beta. So now listen. So when I am drawing a support, this is the support and this is a line. Okay. Now when I am drawing that line, I took a point. Now that point is not proceeding anywhere. A point is not enough to indicate a direction. Understood? At that particular moment, it is considered as null vector. Got it? So how to represent a null vector? So it will become A vector is always considered as null vector. Why? Because initial and terminal, both points are same. So it is considered as null vector. For null vector, initial and terminal points are both same. So when initial and terminal points are same, it is considered as what? Null vector. So when initial and terminal points are same, what it is considered as? Null vector. Another important point, beta, null vector magnitude will always be 0. The null vector magnitude will always be 0. So this is the most important point. Simple tricks, simple technique. If vector command you are having, beta, then 11th and 12th will become like this for you. So only I am telling vectors, understand very nicely. Okay, so what exactly you have studied? AA vector. So whenever you will do magnitude of AA vector is equal to 0 vector, that means magnitude will always come as 0. Magnitude for null vector will always come as 0, and for null vector initial and terminal points will be same. So initial and terminal points same. And it will be indicated as a point. It will always be indicated as a point. Got it? So initial and terminal point same, and it will always be indicating as a point. Okay. Now we will go for the next part. So we are going to talk about unit vector. What we are going to talk about? Unit vector. So when unit vector somebody will be talking about, please see that its modulus understanding unit vector. So this thing, that thing, it was never coming in my brain. To be very frank, I'm saying you. So when they were explaining this is there, that is there, it was a very big problem for me as a student, where the things are not so easy. It was very difficult. So unit vector in my own way. So okay, beta, how to write unit vector? So 1 into 5, when you will write 5, this is unit vector. Because beta 1 is equal to, yes, that's the most important thing. Here is the catch, because I had problem in understanding. So what I did is I was understanding like 1 into 5 is equal to 5. So 1 is equal to 5 by 5. The magnitude of unit vector will always be 1. The magnitude of a unit vector will always be 1 and represented by cap. Got it? So when this is unit vector, then this by magnitude of unit vector, and this is exactly indication. So if magnitude, so if I will write magnitude part like this, then it will become n vector by, so when we are cancelling it, what it is coming as 1. Got it? So magnitude of unit vector is always 1. Okay, so magnitude of unit vector is 1, and unit vector always, unit vector always indicates direction. Understood? Unit vector is well known to give a direction. So we are implementing unit vector for putting direction. So where and all we can't put direction, we are putting unit vector. Just one thing you see, if I am writing AB vector is equal to xi yj plus zk. So what these are? These are exactly considered as unit vectors. So this is unit vector along x-axis. This is unit vector along y-axis. And this is unit vector along z-axis. Is it crystal clear now? Understood. So beta, unit vectors are only put into a vector to give a direction. And what is the magnitude of unit vector? 1. So this is the concept I understood, because it was very problematic for me. They were going like this and telling like this. So it's not understanding. It was not understanding in my frame. It was not ending. So what I did is I understood in this format. Now is it easy? So beta, I cap is unit vector along, say unit vector along x-axis. So for x-axis, I cap is exactly implemented to give direction along x-axis. For y, what we have done, Smriti? So for y, what we have done, you are understanding? For y, when we are putting, so that means it is given direction along y-axis. And z means it is giving along direction along z-axis. So now we are implementing direction in all the three parts. I hope you might have understood this one. Thank you, Smriti. So did you got this part or not? Huh? So this is the most important section, beta. So unit vector always gives what, beta? Direction. Unit vector is always giving direction. So we are implementing unit vector just to give direction. So where and all direction is missing, what we are implementing? Unit vector. Now you see here, we wrote now this is equal to this. Come on, check this one out. The moment you will multiply, this is direction into magnitude is equal to vector. Check. This is a vector. This is direction, and this is magnitude. So magnitude into direction is vector. Note down. For understanding, note down, beta. This is what? Vector. This is direction, and this is magnitude. Story over. So whenever, happy Diwali, beta. So now look here. Whenever, understand this part. Whenever you want to make anything as a vector, you can multiply what into that? Unit vector. So we can easily say that the unit vector into magnitude will become the vector itself. Understood this part? Understood this part, beta? So this is exactly the most important. I'm doing PhD, so I'm in great PhD. So I hope you are understanding this part, beta. So whenever I want to represent any vector, so if this vector I want, what I will do? Its magnitude and its direction. Understood? So magnitude into direction will become beta unit vector. Now anybody will tell you, will you get fooled by them? No, you will not be getting fooled, because now you have a perfect answer. Correct now? So what is the perfect answer, beta? Magnitude into direction is unit vector. Magnitude into direction is unit. Yes, vector is there. Sorry, magnitude and direction is vector. So but unit vector is unit, its modulus will always be coming as unit, and so only beta I said 5 is equal to, this was the easiest way to understand. This was the vector, this was the magnitude, and this was the unit vector. So always unit vector magnitude is, and unit vector is always implemented just to give what? Direction. Understood or not? Is it crystal clear now? So anybody will be asking, and you know what, beta, many times we are doing one work. This in other important section is like this is exactly one vector, huh? Another vector is there. Now this vector, unit vector, will become parallel to this vector, because this vector direction is same to this vector, so this, and they both magnitude is 1. I will teach you these things when I was solving the question. I will teach you these things. I hope you might have understood. So when we will be doing unit vector, from one part we will take and we will implement into the other part. That's also we are going to do. Got it? So now beta, we will go for the next part. Till here we have understood many things about vector. This is the first introductory class of vectors. Vectors. Now collinear or parallel vectors. Are you going to tell anything about collinear or parallel vector? Did you understood collinear or parallel vector? What was about collinear? Vectors having the same or parallel support. I told now, vectors having the same support or parallel support, they are called as collinear vectors, co-initial vector. Now we will understand coplanar vector and co-initial vectors, because they are also one very important concept. Now look here, please pay attention here. When somebody will be asking you what is the meaning of co-initial vector, when two vectors are having same initial point, O, A, B. Understood? So both vectors are having same initial point, same initial point. What it is called as? Co-initial vector. What it is called as? Co-initial vectors. Now when two vectors will have same terminal points, it is called as co-terminal. Understood? Terminal means when the head is joining together, it is considered as co-terminal. Note down. So this is exactly co-initial vectors and co-terminal vectors. Okay. So when two vectors will join coming from the same initial point, it is called as co-initial vectors. When two vectors are joining in the same terminal point, it is called as co-terminal vectors. What it is considered as? Co-terminal vectors. So did you understood about co-initial and co-terminal vectors? Co-initial and co-terminal vectors. I hope you might have understood this one about co-initial vectors and co-terminal vectors. Done? Now beta, we need to understand coplanar vector. Coplanar vector is a different concept. Co-initial means starting from the same point. Co-terminal vectors means when you are merging everything into the same terminal point, it is called as what? Co-terminal points. Now coplanar, a system of vector is said to be planar if their supports are parallel to the same plane. Yes. So you need to understand this is a plane. A page can be also a plane. We can consider a page also as a plane. Got it? So we can consider a page as a plane. We can consider 2-3 pages as 2-3 planes. Understood? Because each plane is 2-dimension. Each plane is 2-dimension having x-axis and y-axis. Understood? When we will take its width, then it will become 3-dimension. But when only we will take a page, we will not take the thickness of the page, only we will take length and breadth, then it is what beta? 2-dimension. Right now this board thickness we are not using, we are only using the length and breadth, then what it is exactly considered as? 2D. Understood? But when we will consider its thickness, it will become what? 3D. So this is the basic difference between two-dimensional and three-dimension. Now here, so this is a coplanar. So this is a planar part, plane. Understood? So when a parallel vector can be parallel to the plane section, this is considered as the vectors will be coming from the support and it will be parallel to the plane. It is considered as what? Coplanar vector. A system of vectors, not one vector. A system of vectors is said to be coplanar. A system of vectors is said to be coplanar if their supports are parallel to the same plane. If their supports are parallel to the same plane. Understood or not? So the supports are coming parallel. Understood? Supports are parallel, then it will be exactly considered as what, beta? Coplanar. Got it? So we need to make one plane, and whatever vectors are coming as a system parallel to that coplanar, means if this is a page, understood, and whatever lines I am drawing parallel to the page, either this side, that side, they will be exactly considered as what? Coplanar, because it is on the same axis. It is on the same axis, so it will be considered as what? Coplanar. Understood? So if one page I have taken, another page I have taken parallel to it, and I have drawn 2, 3 like this. So they are exactly considered as what? Coplanar, because axis is same. What is same, beta? Axis is same here. So what it is going to be considered as? Coplanar. I hope till here it is beta. Yeah, vectors will be, that time system will be from this inside vectors also. Yeah, but beta, see, when we are taking that will come as planar, na? No, it is in the on the same plane, na? Co means coming from the nearby axis, same axis. Understood? Yes. So if one sheet I have taken, I will draw something parallel outside, then it is considered as co. Co-planar means with system. Are you understanding the word? What is why it is from the same plane we are taking, means the vector in the same plane means same axis. Understood? But one plane paper I have taken, outside the plane paper, 2, 3 parallel supports I have drawing. The total system outside the plane paper, that means what? It is considered as co-planar because it is in the system but outside of the plane. So it is considered as co. Understood? What is the meaning of co-pilot? No, it's not like, no, it is from the same plane support. Same axis will be coming that time. But what is the meaning of co-pilot? Co-pilot? One who is driving, one who is exactly driving the plane, another one is also in the cockpit present. At the time of need, the second one will be used. That is exactly done. So here on the same board, if I will divide the board into two segments, one plane and another plane, and whatever vector here and whatever vector will be here, they both will be exactly considered for the co-planar. Understood? Is it crystal clear? No doubt here and there? Got it? So many times now students are having confusions related to it. Otherwise, we will say from the same plane now. In the same board, when we are drawing multiple vectors, why we are going to talk about as a coplanar? Correct now? Simple concept. When two papers I will take, yeah, paper axis, yes. The edges will be exactly, it will be parallel to the edges, near to the edges when it will be there. That will be exactly considered as co-planar. So I hope you have understood this concept. So now we will be going for coterminous vector. Right now only I talked when both the head of the vector merges together, it is considered as what? Coterminous vector. What it is considered as? Coterminous vector. So when the heads are merging together, this will be considered as what? Coterminous vector. Till here, Shivaranjani, is it? And are you there? Did you understood? Got it? So this is considered as what, beta? Coterminous vector. Now, whenever someone will be talking about negative of a vector, so when you will be talking about negative of a vector, localized and free vector, we are going to discuss. Negative of a vector means what? So if one person is going from here to here, A to B, this is exactly considered as AB vector. But when you return it, the direction is exactly changed. The terminus point is changed. So BA vector will be negative of AB vector. BA vector will be negative of AB vector. That's what is called as negative of a vector. Negative of a vector will have same vector negative if you are finding, then you must remember same vector negative if you are finding, then you must remember their magnitude will be equal but direction will be opposite. Understood? Same vector negative finding means magnitude same. What is same? Magnitude same, direction opposite. Magnitude same and what is opposite beta? Direction opposite. Got it? So magnitude will be same and direction will be opposite. This is exactly considered as vectors having opposite magnitude, negative of a vector. So negative of a vector will always be drawn opposite to it. Negative of a vector will always be drawn what? Opposite to it. I hope you might have understood this one. Till here, is it crystal clear? Understood the concept to that level, beta? That is negative of a vector, opposite vector, everything okay now? But then how was the vectors class? It's understandable. You are able to write your understanding. So better whatever questions or vectors will be there, I'll explain every single question because vector is that topic from where you can be able to touch all the questions and you can be able to get full mark. Are you understanding? But concept has to be totally clear. If concept is clear, then only you will be able to get full marks. Otherwise, not possible because you will do some mistake, silly mistake means the story will become over. So one question is there NCRT question. First, we are going to dig and solve. Are you ready for it? Now, beta, what is the meaning of free vector and what is the meaning of localized vector? So this is exactly a very simple concept, but yes, it is very, very important. What is the meaning of free vector? So when the vector, any vector which do not have any localization, means which will not be connected to any terminal point. So what is the meaning of initial point? See, the region from where you are exactly going. So this is exactly considered as free vector. Free vector means what, beta? So here it is exactly present in a room. I will take one dust particle. That is a free vector. Why? Because it is not at all connected to room. Any one of the edges, the moment it will connect to that dust, it will become localized. But if I will take a vector, a vector along with origin, then it will become localized. See, for localization of a vector, you need axis. Understood? You need origin because you can be able to find the distance of the vector from the origin. So when your parent has given you permission to go till Chennai, what it is that? Localized. Why? Because you know that what is the area till where you can go. So any vector which will be having axis as the part who can indicate its presence, that will be considered as what? Localized. Which one? Origin is not axis. Origin is away from axis, but we can be able to localize like this, na? Yes, you can measure it. So when you are able to measure it, it is considered as what? Localized. But when a vector will be out of control of anything, only magnitude and direction is there, then it is considered as free vector. Understood? So when you will not create any connectivity with the origin, when you are not creating any connectivity with the origin is called as free vector. A vector having no connection with the origin is called free vector. A vector which will have connection with the origin is considered as localized vector. Did you understood the connection here? So here we must understand that whenever we are generating a connectivity with the origin, it is called as what, beta? Localized. But when we are not generating any connectivity with the origin, it is considered as what? Free vector. It is considered as free vector. Till here, is it crystal clear? Understood? Now we have exactly turned to something. So now beta, a vector if 5 times multiplied to magnitude, we can exactly extend its magnitude. Got it? So vector multiplication with some constant number can increase its magnitude, and direction remains the same. Direction remains the same. So magnitude multiplication means any number multiplication with a vector will increase the magnitude of the vector. That is also possible. But one case must be there, direction remains the same. Direction should not be changed. Means after implementation of a magnitude or a number multiple to the vector, then we should not be changing the direction. Understood? The sense and the direction, the sense should be same from the support side. The sense should be same from the support side. So that is exactly considered as the magnitude part of it. How was the class today? Understood the vector sense beta? So the vector part, because case study coming from vector means we should be boss. Got it? So till here understood now. Tomorrow also I am conducting one class. Okay, tomorrow I am going to keep common class. All the triple quantum student also I wish to call here. Okay, so that all of us will have a common class morning time itself, because schools are holiday now. Tomorrow exam is there. Okay. Tomorrow what exam is there? English. Okay, after exam can we keep the session? Okay. Oh, after 4 o'clock is it okay? Oh, till 4 o'clock. So 5 o'clock. Ninth 5 o'clock beta. Okay, bye everyone. Huh? Do they have special class? Hi beta. Hi Ranjit. You are from which class, Ranjit? So please kindly refer the vector videos beta. Just now class is over. Okay, Ranjit? Okay, but better listen. Vector introduction I have given. Nicely, we have understood the vector introduction. Dropper. तो क्या हुआ? Dropper मतलब क्या? So now look here, beta. So you need to understand one thing, that we must be going with the league and we must be understanding the part. Okay. So tomorrow our main focus should be going to solve unit vector related questions, parallel related questions. So introduction to vectors part. After that, dot, cross, and then 3D we will be touching. Okay. So single videos we will be making, and single part we are going to understand. Today we have understood the introduction of vector, what and all were there, sense, support, and length. Understood? After that we understood about the magnitude. Ranjit, timetable beta, whatever time, evening time will be there. Evening time will be there. Most probably 6 o'clock or 6:30 class will be there tomorrow. Okay? From my side, whatever support is there, I'm going to provide you. Okay? Bye beta. You can see this video and learn. Very simple way I have taught vectors.